Good morning, class. I'm Mr. Bello. You are welcome to another Saturday's online lesson. Before we go into today's topic, looking at the board, you will see correction to last Saturday's assignment. So please look at it and compare it with the one you have done. If there is any correction to make, then you can make it. Oh, yeah, I will tell you to start when I want it. Now we want to look at today's topic and its Pythagoras theorem. Looking at the board, you can see the theorem stated by Pythagoras, the mathematician that came about this theorem. What is he talking about? It's all about a right angle triangle. You can see a right angle triangle here is different from other triangles because one side is 90 degree, and you can see this point, this sign shows that this place is 90 degree, this one is 90 degree. So this is the type of triangle that the Pythagoras theorem is applicable to. Now what does the theory say? The theory says that the squares on the hypotenuse, the squares on the hypotenuse side is equal to the sum of the squares on the other adjacent sides of a right angled triangle. Now let's look at this first diagram. I want to call it, name it 1, this one is 2, this one is 3. In this triangle, this arrow is pointing to the hypotenuse side, which is the longest. The side that is facing the right angle triangle here is always the hypotenuse. Looking at triangle 2 is taking another dimension, but what is important is to locate the right angle triangle and trace it to the line facing it. Look at it, this is the longest side. The same thing is applicable to figure 3. You can see the right angle triangle here is facing the longest side. It's very important we use this method to locate the longest side, because sometimes the right angle triangle, the sides, the length of the sides may be a little, the difference may be very small, that you may not be able to locate the longest side just by looking at it. Now let's come back to the theory. The squares on the hypotenuse, this is C, hypotenuse is C, the square on the hypotenuse, let me put it like this, is equal to the sum of the squares on the other adjacent sides. Where are the other adjacent sides? A and B, equal to the squares. So that sum will give me plus. The squares on A is this, the squares on B is this. This is all that the theory is talking about. The squares on the hypotenuse C is equal to the sum of the squares on other sides of the right angle triangle. This is all the formula you need to solve any right angle triangle given to you. When you're calculating the length of it, you use this formula. We are going to look at example so that you can understand the theory very well. It's all right. Let's look at the example. We have to find the length marked with letter in each of the following triangles. All right, let's look at this example. This is A, this is B. Looking at it, you will see that this is the hypotenuse in A, and in B, the hypotenuse is here. So let's look at what we have here. From the theorem, this is the hypotenuse. Okay, we don't know what it is. So let's assume that the hypotenuse is C. So we are going to say C square equals, these are the two adjacent sides, 3 and 4, equals 3 square plus 4 square. So that means we have C square equals to 3 square is 3 times 3, that will give you 9. 4 square is 4 times 4, that is 16. When you add 9 to 16, it gives you 25. C square equals to 25. Now let's get what the value of C is. by taking the square root of both sides. You say c square. Okay, this square we cancel this square root equals to the square root of 25. You are left with c here. The square root of 25 is 5. That means that the hypotenuse side is 5 meter. 5 meter. Let's look at question B. The hypotenuse there is also unknown. Let's say the hypotenuse is C. The other two sides, okay, sorry, the hypotenuse is 10 meter. The hypotenuse is 10 meter, and the other side is 8 meter, then the third side is unknown. Now let's start with the hypotenuse, which is 10 meter. That is 10 square equals 8 square plus x square. This 8 square and x square, they are representing a square and b square from our formula. Now 10 square is 10 times 10, which is 100. 8 square is 8 times 8, that is 64. Then x square, we don't know. From this point, we are going to isolate x square, or we collect like terms. When you collect like terms, you will move this 64 here, and then you leave this x square here. You have 100 minus 64 equals x square. When you subtract 64 from 100, you have 36 equals x square. So we get the square root of both sides. That we have the square root of 36 equals x. When you put square root here, this square will vanish away. So you are going to have your answer to be square root of 36 is 6. 6 equals to x, or you say x equals 6 meter. So we have seen the two situations that you can come across using Pythagoras theorem, where you have to calculate the hypotenuse. You can see in this case, there is no need for subtraction. We just add straight because the hypotenuse is not known, but other two sides are known. The second example, the hypotenuse is known, but one of the other two sides is not known. So that is why we have to subtract the other side from the hypotenuse and get the square root of both sides. Then this one will give you 6 meter. Let's look at another example. This one is a little bit difficult than these two, but it's still the same method. It's very simple when you apply it. Two triangles joined together. And when you look at it, you will see that in the first triangle, that is triangle 1, there are two sides known, 3 centimeter and 2 centimeter. In triangle 2, we have 6 centimeter. The other two sides, we don't know it. This one is x, this side we don't know it. So to solve this problem, you will have to solve triangle 1 first. Why? Because you know two sides of triangle 1. For Pythagoras theorem to be applicable, the triangle must have at least two of the sides. So let's pick out the first triangle. This place is 2 centimeter, this place is 3 centimeter. So this is the hypotenuse. This is the hypotenuse. Okay, this place is the hypotenuse. So let's let's say that this hypotenuse here is C. So I'm going to have C squared equals 3 squared plus 2 squared. So that means C squared is equal to 9 plus 4. 9 plus 4 will give you 13. So it means that C squared equals 13 centimeter. Now I'm not going to get the square root of 13 because I want to use it here. Using it here in this form will make the job here very simple for you. Now let's look at the second triangle here now. Triangle 2. Let me draw it here. This is what we have in the second triangle. This place is x, this place is 6 centimeter. So we are calculating the value of x, and x is facing this right angle triangle, making it the hypotenuse. Don't forget, we have calculated the value of PR. We have gotten PR squared to be 13 centimeter. So let me put a letter in this place. Let's say let me put Y here. Or no, let's put C in this place because we are already C here. Now let's start with x. X hypotenuse side. So I will say x squared equals C squared plus 6 squared. Sorry, this place is supposed to be equal sign. So we are going to have x squared equals, we have calculated 6 squared before to be 13. We just put 13 here. And 6 squared is 6 times 6, which is 36. So we have x squared equals, when you add 13 to 36, 3 plus 6, you have 9. 1 plus 3, you have 4. You have 49. So you get the square root of both sides. You have x to be equal to the square root of 49. You have x to be equal to 7 centimeter. So that is it. The value of x is 7 centimeter. X equals 7 centimeter. This place is 13 centimeter. This is 8 centimeter. This is 5 centimeter. This is your assignment in number 2. You have to look at it very well. The triangle you first solve to make the work easy for you.